myself Karthikeyan, Assistant Professor, Department of CSBS, KS Rangasamy College of Technology, Tiruchendur. So welcome to today's sessions on Unit 2, Tuple and Domain Relation Calculus. So in this unit, we are going to learn about two important topics in database systems. So relational algebra and relational calculus. So before we begin, how many of you remember relational algebra from last unit? So okay, let's refresh and then dive deeper. So next one is basic operations of relational algebra. So in relational algebra, there are some basic operations like selection, projection, cross product, and set difference. So here selection we use the symbols named as a sigma, and the projection symbol used as a pi, the cross product used as a cross symbol, the set difference used as a minus symbol, the union used as a union symbol. This is a symbols of the base operations involved in relational algebra. So basically selection operations selects the subset of rows from a table. So the projections delete unwanted columns or particularly display the particular attributes from the database. So cross product combine two relations. So which means in a database two relations can be combined into single relation. Set difference gives tuples in one relation but not in the other. The unions takes tuples from both relations. So we also have additional ones. The first one is intersection, join, division, and renaming operations as well. Now, why do we say relational algebra is closed? Because each operation returns a relation. That means we can apply one operation after another, like building blocks. So this is known as relational algebra. The next one is example instance. To make our learning easier, we will use some example relations. We have relations called sailors, so and then reservoirs, sometimes written as R1 and S1, so and S2. So these are the three different relational tables used to get the operations from the conditions. So these are small sample tables that help us practice the operations. Remember, field name in the result are usually inherited from the input relations. So we don't have the rename unless there is a conflict in database or a particular relation table. So this is an example instance that we are going to use in further queries. So the next slide, projection. So now let's see the projection operator. Projection removes the attributes that we don't want from the relation or database. So the schema of the result will contain only the fields listed in the projection. But there is one important point: projection must eliminate duplicates. Why? Why? Because relations are defined as sets, and sets don't allow duplicates. But in real systems like SQL, duplicates are not. But in real system like SQL, duplicates are not removed unless the user asks for it. So why do you think so? Because removing duplicates takes extra time. That's only we can't able to remove the duplicates. So this is a projection operator. The next one is selection. So selection choose rows that satisfy a given condition. For example, age greater than 30. The schema of the result is exactly the same as the input relation, and there are no duplicates in the result. So we can use the result of a selection in another operations. Says it is called operator composition. So this is a selection. The next one is union, intersection, and set difference. Now union, intersection, and set difference are all need to two input relations. So without two input relations, we can't able to perform any operations from union, intersection, and set difference. So there is a condition: they must be union compatible. And that means two things. The first one is same number of fields. The second one is corresponding fields must have a same types. So if two relations are union compatible, what will be the schema of the result? Yes, it will be the same as inputs. Union gives all tuples, intersection gives only common ones, and set difference gives what is in one relation but not in the other. So this is a union, intersection, and set difference. So the next one is cross product. The cross product or Cartesian products. The cross product will be called as a cross product or Cartesian product. So each row of S1 is paired with each row of R1. So each row of yeah. So this is a S1 paired with R1. The result schema has one field for each field from both, but there comes a problem. What if both relations have a field with the same name like SID? So already we know, if suppose we have the same name field in the while combining the two relations, suppose we have the same name field means we have to rename the particular attribute. So this will create a confusion, so we use a renaming operator to solve this. So the next one is join. A join is simply a cross product followed by a condition. For example, S1 into R1, but only where S1 dot SID and R1 dot SID. The schema is the same as the cross product, but the number of tuples is fewer, which makes it more efficient. So what is another name for this type of join? It is a theta join. So for join operation we have another name called theta join. So the next one is relational calculus. So now we shifted from relational algebra to relational calculus. Remember, relational algebra is procedural. It tells how to get the answer from the database. Relational calculus is declarative. It tells us that what we want from database. So relational calculus come in two forms. The first one is tuple relation calculus, basically known as TRC. The second one is domain relation calculus, which will be represented as a DRC. So it uses variables, constants, comparisons, logical connectivities like and or not, and quantifiers like and qualifiers like and there exist. Both TRC and DRC are subsets of first order logic. The expressions are called formulas, and the answer is a set of tuples that makes formula true. So the next one is tuple relation calculus. So in TRC, a query has a form like capital T in the vertical bar, then condition. P of T is a condition. This means return all the tuples. T is known as return all the tuples such that the condition P of T is true. So once the condition is true, then only the result will be displayed in the particular T. So the D basically holds the result of this condition. So after condition satisfied, the result will be stored in a particular T. The formula is built step by step. We start with the atomic formulas. For example, taking tuples from our relations or comparing values, then we combine them into bigger formulas using logical connectivities like and or not. So TRC is more about what we want, not how to get the data from the database. So the next one. So this is a tuple relation calculus, and then thank you. Today we studied relational algebra and its basic operations. So example instance like sailors and reservoirs. So there is a three reference tables. The difference between projection and selections, set operations, cross product and joins. Finally we understood relational calculus, TRC and DRC. So always remember, relational algebra is the procedural and relational calculus is a declarative. So thank you so much. We will see in next class.